Good day all and welcome back to the channel. If you are a subscriber and you've been following us for quite some time, welcome back. If it's your first time viewing one of our videos, please do subscribe, and we hope that all the videos that we have published and will publish in future will contribute to your success in math. Today we will run through another topic. This is a term 4 topic for grade 8 as well as grade 9, and that would be area and perimeter of 2D shapes, which are polygons. Okay, so today's video will be one of 3 videos that we'll post focusing on different aspects with regards to 2D shapes. So today we'll run through all the formula for different polygons that you will utilize in your workbook or in your class, or if you are studying, in order to prepare you for your exams. Then the second video will calculate areas and perimeters of shapes that are put together. Those would be mixed and matched shapes with regards to triangles, squares, rectangles, circles, semicircles, so on and so forth. And then in our third and final edition with regards to this module, we will show you how to calculate the shaded areas of shapes. Okay, so before we carry on and do all of this, let's quickly run through the definitions that we are going to work with regards to the polygons. Okay, so first of all, if you look here, we've got perimeter, and the perimeter of a shape, let me just draw a shape here. Someone just draw a rectangle. So the perimeter of a shape is obviously the distance covered around the shape. So if you've got a fenced off area and you walk around the fenced off area, that would be the perimeter of the shape. Then we've got area. So area would be the amount of surface space. So area is everything inside the fenced off area. So the amount of surface space covered by an object. This is also measured in square units. So if you don't know what that means, is inside the shape there's a grid, and this grid forms squares, and all of these squares together would give you the actual area of the shape. Okay, so all these squares together multiplied together would give you the area inside the shape. Okay, so it's obviously the amount of space that the shape covers. Okay, so let's quickly jump into our first polygon that we'll be looking at, and that would be a square. So we're going to look at squares quickly. So squares are your most common and basically your easiest polygon to calculate the perimeter as well as the area for. Okay, we just draw a square here. Okay, and then we say this is 6 meters. Okay, first things first, we might give you all the measurements for the square, or we will ask you or assume that you know your properties of your shapes. Okay, so with regards to a square, you need to know that each and every side of the square is equal to one another. Okay, so all these sides are equal, which means if this is 6, then this side will be 6 meters, 6 meters. Okay, and just to add on to that is that the properties were learned when you did geometry of 2D shapes. Okay, it should be in your book. You should know it off by heart, and make sure that you are able to differentiate between the properties of the different shapes in order to complete your questions. Okay, then the first thing that you're going to look at is obviously the perimeter. So the perimeter of the square, and with that you are allowed to use 2 formula. Okay, so the first formula would be the one that you learned in primary school, where the teacher said to you that you had to say length plus length plus length plus length. Now remember that a square does not have a breadth. Okay? A rectangle has a breadth. Because all the sides are equal, we work with lengths. The same with triangles. You always work with lengths, not lengths and breadths. Okay? Then, the other formula that you can use is this formula, where we say 4 times the length. Because all the lengths are equal in size, or equal in, all the sides are equal in length, you are allowed to say 4 times length. Okay? So just to give you a bit of clarity on this, I'm going to do the perimeter for both the formula at the bottom here. So for the first one, and this would be the primary school method, we would say 6 plus 6, because they're all the same, plus 6 plus 6. And that would all be equal to 24 meters, because that's the unit of measurement that was given to you to work with. Or you could use the other one where you say perimeter is equal to 4, and in the variable position we open a bracket and we say times 6. 4 times 6 gives me 24, and that would be meters. Okay, so any of the two formula would work in this regard. Okay, moving on to the area for a square, we would work with the following. So there's only one formula with regards to the area, and that would be area is equal to length times length. So length times length. Okay, so when we do this, we're basically just going to say 6 times 6. Remember, you can do 2 brackets, or you could write it out as follows: 6 times 6, like that. You still get the same answer, it means the same thing. So 6 times 6 would give me 36 meters, and then it would be squared, because remember, it covers the surface in squared units. So 36 meters squared in this regard. Okay? That is it for the formula for squares. Let's quickly move on to rectangles. Remember that this is just a basic video to teach you all the formula, as well as the procedures to follow to calculate both the perimeter as well as the area of the shapes. So rectangle. Again, with rectangles, you need to know the properties of your shapes. Okay? So here's a rectangle. All my shapes are a bit off balance and out of line. So if I tell you that the length is 8 centimeters and the breadth is 3 centimeters, you need to understand the following. Okay? Is that a rectangle has 2 pairs of sides that are equal in length. And those 2 sides would be as follows. So the side at the top here would be the same length as the side at the bottom. The side on the right, the same as the side on the left over there. So this is 3 centimeters, that is 3 centimeters. 8 as well as 8 at the bottom. Okay? So the perimeter of the rectangle would be calculated as follows. So perimeter, look as follows. So it would be P is equal to length plus breadth plus length plus the breadth. That is the primary school method that they showed you. The other formula that you are allowed to use would be 2 times the length plus 2 times the breadth. Okay? To put this in perspective for you, we are going to calculate everything over here. So this would be 8 centimeters. And remember, this is 3 centimeters. And our unit of measurement here is centimeters. Okay? So P is equal to, the length would obviously be 8. That's your longest side. Plus 3 plus 8 plus 3. So if I add all of this together, I should get 22 centimeters. So 22 centimeters. If I use the other formula, I should get the same answer. Okay? So P for perimeter is equal to 2, open bracket, the length is 8 plus 2, the breadth is 3. So 2 times 8 is 16 plus 2 times 3, which is 6, and 16 plus 6 gives me 22 centimeters in this regard. So there is how you calculate the perimeter in two different ways for a rectangle. Moving on to the area of a rectangle, and that is calculated as follows. So for the area, we've got the formula looking like this. So A is equal to length times breadth. Remember, a rectangle has a length as well as a breadth in this regard. Okay, so the length is 8, and then the breadth we've got as 3. Remember, you are also allowed to write it like this, 8 times 3. I just like to prefer the brackets method. It just makes it easier and it looks neater. Okay, so at the end of the day, if you say 8 times 3, that would give you a total of the area space of the rectangle of 24 centimeters squared. And there it is calculated for you. Okay. Okay, moving on to triangles. Now, triangles, this is where it becomes a bit tricky, because in grade 8 and 9 you should now know how to be able to calculate the sides of a right angle triangle with regards to the use of Pythagoras. Let me just write triangles. There we go. So triangles. So obviously they will give you something like this. Let me just draw it for you here. And then they'll tell you that triangle ABC looks as follows. So they'll give you this, and then they will show you that it's a right angle triangle. So line A is perpendicular to BC. Okay, so that's what they're basically telling you. So if they're telling you that A is perpendicular to BC, it means that it meets the base at a 90-degree angle. Okay? And then we tell you that this is 8 centimeters. The total BC is 8 centimeters. And we tell you that this side is 6 centimeters. And then we put in these little markers over here. Okay? Now obviously these two markers tell you that these two sides are exactly the same length, which means that you're dealing with an isosceles triangle in this regard. Okay? Which means if these two are the same length, then your base angles should be equal. Okay? Now, what you need to understand is that we will normally ask you to calculate the height of the triangle. Please don't mistake the sides that are diagonal with the height of the triangle. Okay? Your whole calculation will be wrong. So, when calculating for the height of the triangle, you need to understand that the full length of BC is 8 centimeters. Okay? And when you calculate the height of the triangle, that you only work with 1/2 of the triangle, and that would be the right angle triangle. It could either be this side on the left, or it could be the triangle that's on the right. Obviously, if A meets BC perpendicularly, you could work with any one of the two. Okay? So, the other thing that you need to understand is that if the total length of BC is 8, then this side over here and this side over here should be equal if you split it up into two right angle triangles. So, when calculating the height, you would work with 4, because you're only working with 1/2 of the triangle. Okay, so before we do the perimeter as well as the area, we need to calculate the height of the triangle, because you're going to need the height of the triangle in order to calculate the area of the triangle. So, let's start with the perimeter, and then we'll move on to the area as well as the Pythagoras theorem. Okay. Now with this, because AC is 6 and AB is equal to AC, then this side should also be 6 centimeters. Okay. So calculating the perimeter, of the triangle, you need to understand that, like I said to you, with regards to a square, a triangle works similar to a square, where we speak about lengths. There's no breadth. So it would be length plus length plus length. Now please don't tell me 3 times length. The only triangle that can be calculated as 3 times length is an equilateral triangle, because all the sides are equal in length. You cannot use that formula on an isosceles triangle, a right angle triangle, or a scalene triangle. You are going to mess up the calculation. Okay? So 3 times length only used on equilateral triangles. Okay? So with regards to this, I'll start on the left. So we'll say 6 plus 6 plus 8 at the bottom here. And if I calculate all of that, I should then get 20 centimeters for the perimeter. And there we go. Done, dusted, that's the perimeter. Okay? So obviously the distance around the shape, 20 centimeters. Now for the area of the triangle, in order to calculate the area, I need to calculate the height. And for that, I need to use Pythagoras. So, your standard formula for Pythagoras. So I'm going to write here Pythagoras. What am I doing? So the standard formula for Pythagoras, okay, is r squared, which is your hypotenuse of your right angle triangle, is equal to x squared plus y squared. Okay, so I'm going to work with AB over here. So if I redraw it, it will look like this. So A is there, B is here. Then obviously this side over here and this would be the same, so this should be 4. Okay? And then we've got 6 centimeters here. And this should be 4 centimeters. We need to calculate the height. Okay, now let me explain this to you. If you haven't watched the other video that I made on Pythagoras. R is the hypotenuse, and that would be side AB, which is the longest side of the right angle triangle. X squared is the base, which is obviously, if you draw it on the Cartesian plane, it would be the horizontal axis. Okay? Y is the height, which is always your vertical axis on your Cartesian plane. Okay? So, when we go and substitute this, R is 6. So we open the bracket, put 6, put square, and then equal. X, we've got, that is 4 squared. Then the height is what we are looking for, which is y squared. Okay, so 6 times 6, please don't say 6 times 2. The exponent tells you that you need to multiply the base by itself. Okay, so 6 times 6 is 36 equals 4 times 4 is 16 plus y squared. Now, we've got 36. We need to carry the 16 over because we want y as the subject on its own. So it becomes negative 16 is equal to y squared. If we subtract this, it becomes 20 equals y squared. Now, here comes the trick. We need to square root both the left side as well as the right side because it's an equation. So, square root of 20 and square root of y. So therefore y is equal to the square root of 20. Now you're going to ask me, why did I not write it out as a decimal? The reason for that is because when you calculate the area, you want to round off right at the end. So use the square root of 20 as is. Okay, so the height of the triangle now is the square root of 20. And that is what we're going to use to now calculate the area of this entire triangle. Now, remember with Pythagoras, remember with Pythagoras, we only used 1/2 of the triangle to calculate, okay? But when you calculate the area of the triangle, you need to use the entire base because it's half the base times the height. So the area formula is A equals half the base times the height of the triangle. So, what we do then is we say half, and then the base is 8 then the height is obviously the square root of 20. Use it as is. You're going to round off right at the end here. Okay? If you don't use it as is, then your answer might be a bit off from what the memorandum says that the teacher needs to use when assessing and marking your papers. Okay? So, if we multiply all of this together, so obviously you multiply these two together, and the half multiplied with the answer would cut the answer in half. So, your final answer rounded off to 2 decimal places should be 17,89 centimeters squared. And that is your final answer for your area of your triangle. Okay? That is it for the area and perimeter of triangles. Now let's quickly bounce into circles. Now with circles, I'm going to quickly talk about 3 different circles. So obviously your full circle, a semicircle, as well as a quarter circle. So let me just throw it in here. Circles. And this would be full circles. Okay, so I'm just going to say a full so you understand what I'm saying or what I'm talking about. So full circles would obviously look like this. There we go. As well as they will give you something like this. So I'm going to do the radius. Let me do 40 meters. Or rather the diameter. I do apologize. So the diameter of the circle, remember the circumference. The circumference of the circle is the distance around the circle. That is what you call the perimeter. Then the area is obviously the space that it takes up here. So with regards to the perimeter, or let me call it the perimeter, but it's actually called the circumference. With the circumference of the circle, to calculate the circumference of a full circle, the first thing that needs to happen is, if they give you the diameter, you need to go and calculate the radius. So the radius of the circle would obviously be the diameter divided by 2. So we take the 40, we divide that by 2. So at the end of the day, your radius would be 20 meters. So from the center to the circumference, it would be 20 meters. And then your diameter would be from the circumference through the center to the other side of the circumference. Okay. In this case, to calculate the circumference, meaning the distance around the circle, you need to use this formula. So C is equal to 2 pi times radius. Okay, 2 pi times your radius. So to calculate the circumference, we're going to say 2 pi, you use it as is. Remember on your calculator, let me grab mine so I can show you here. So on your calculator over here, you're going to press shift, and then you'll press pi right at the bottom here. You'll be able to see it there. And then you use it as is. Okay, your radius is obviously the 20 that you've calculated over here. So to calculate that, we'll say 2. So you're going to say 2, shift, then we press pi over here. You'll see it comes up on the screen. Open bracket, 20, close your bracket, and then you press equal. Now obviously it will give you something like this, which is 40 pi. You can write that down. But we're going to ask you to go and round it off to 2 decimal places. So what you do then is, you would see over here is an SD button. It takes it from the form that it's in, and it converts it to a decimal number. So as soon as I press it, you'd see a decimal number come up. And then you need to round it off to 2 decimal places, which means you'll have a look at your third decimal. If it's lower than 5, your second decimal stays as is. If this is 5 and higher, your second decimal will round up one number higher than what it is currently. Okay, so at this stage we'll have 125,66 meters, and that would be the distance around this full circle. Okay, now to calculate the area for this circle. I just want to move my board over because I think I want to do area right next to it here. So the area over here would obviously be as follows. So we say A is equal to pi times radius squared. So the 2 that you would have here for the circumference, you would take and you'll throw it up over here now. Okay, same thing, pi stays as is. The radius we've calculated, which is 20, put in brackets and put the 2 on the outside. Now to calculate the area, we will go to the calculator again. We will then say shift pi, open bracket, 20, close your bracket, and then you'll see that there's a little square button there. Press that button, it brings it up. Press it and you'll see it will give you again what we got here, which is the standard form, but we want the decimal form. So it's 400 pi. And then we obviously, to convert it, we press the SD button. And there we go, 2 decimals again. That's what we want. So over here you'll see that in the 3rd decimal place there's a 7, which means it's higher than 5, which means we're going to round the 3 up to 4 now. So your final answer will then be 1226,64. And because it's square, it covers squares, we're going to say meters square. Okay, and there is how you calculate the area and perimeter of a full circle. Let's quickly run to a semicircle. So that for those of you that do not know what a semicircle is, it's half of the circle that you are currently seeing that is displayed here. Okay, we quickly do this. There we go. So semi, I'm just going to write semi here so that you guys can see what's going on. So semi. And the circle I'm going to choose, I'm simply going to put upside down. Oh, there we go. Oh, what's happening here? Okay, up, there we go. So, I'm going to give you the diameter again. Let's make the diameter 20 centimeters in this regard. Okay, with that, to calculate the perimeter, of the semicircle, it works a bit different than with your full circles, okay? And the reason for that is not because you're not working with a full circle, so which means you need to divide the actual formula by 2. Now there's 2 ways of doing it. You can either divide the answer by 2 to get half of the circle's circumference, or you can simply just add it into your you can simply just add it into your formula right at the beginning. Okay, so what we need to do is we're going to say C for circumference, then we're going to say a half, because it's half a circle, open bracket, 2 pi times radius. There we go. The other thing that you need to understand is that they gave you the diameter. We want the radius, so you obviously need to go calculate the radius. Okay? So how we do that again is take the 20, so R equals D divided by 2, which is your diameter, 20 divided by 2, and that would give me 10 centimeters in this regard. Okay? So, to calculate the circumference, we're going to say a half, open bracket, 2 pi radius, which is 10, and then we close it off. You put it into your calculator as it is there. Obviously you know now how we're going to do it. And let me just do this. There we go. I'll show you now what it looks like. So it should look something like that when you put it into your calculator. Press, and it will give you 10 pi. So 10 pi, and obviously we press the SD button to give me the decimal display of the answer. So the 5 in the third decimal place is bigger than the 4, so obviously bigger than 4, so we're going to round up the second one to 2. So it will become 31,42, and it will be centimeters in this regard. Okay. Now for the area of a semicircle. Okay. for the area. Now remember your area, we also use the radius for the calculation of the circle. So we're going to say A is equal to, and what you do is we're going to say half the pi times radius squared. And why do we say half pi times radius squared? It's because we only have half of the circle. So a half pi, your radius is obviously 10, and we square that. Let's put that into the calculator. So you have a half times pi, and then times 10 squared. So it should look like this after I've put it in. When I press the equal sign, it should give me 50 pi. And when I press the SD button, it should give me a decimal. So again, the third decimal is a 9, so we're going to round up the second one. So my final answer should be 157, 0.08. And that would be centimeters squared, because we calculated area. Okay. Our final circle that we're going to look at would be a quarter circle. Quarter circle, it's the most commonly asked. Quarter circles, semicircles, as well as full circles. So quarter circle. There we go. And it would look something like this. Hopefully my drawing skills are on par. There we go. Okay. Obviously this would make a 90-degree angle, but it doesn't matter. Okay. And then obviously they'll tell you something like this is 50 millimeters, for instance. Let's use millimeters. We haven't used that yet. Okay. So for a quarter circle, to calculate the perimeter, same as what we basically did with the semicircle. So it's C equals, and instead of putting a half, we put a quarter, because you're only working with quarter of a circle. Open bracket, 2 pi times radius, close your bracket. So when we're going to calculate it, it should be a quarter, 2 pi, and then the radius is obviously 50. And then we're going to put it into our calculator, which would now be 1/4. Open bracket, we'll have 2 pi, open bracket 50. So when you put it in your calculator, it should look something like that. Okay? Press the equal sign, it gives me 25 pi, but we're looking for 2 decimal places, so we're going to press the SD button. And that gives us 78,54, and that would be millimeters for the distance around the quarter circle. For the area, exactly the same as what we did with the semicircle, but yet again, instead of putting a half, we're going to put a quarter, because you're only working with a quarter of a circle. Pi times radius squared. So it's a quarter. Pi radius would be 50, and then square. So when we go and put in everything, we should have a quarter. Shift pi, open bracket 50 to the power of 2. So it should look like that after you've put it in to the calculator. You press the equal sign, it gives me 625 pi. After that, press the SD button, because you're looking for the decimal value, so it would then be equal to 1963, now obviously if you've got a 9 over here and the third decimal is 5 or higher, you're going to round it up. So the 9 would become 10, which means you'll round up the first value. So the first value would be 5, and the 9 would become 0. So you will have 50, and that is basic stuff that they had to teach you in primary school already. Okay. So guys, anytime that a circle is not a full circle, but it's broken up, let's say that gave you 1/8 of a circle, then your fraction will change to 1/8. Doesn't matter what you're calculating. If it's a tenth of a circle, the fraction would change to 1 over 10. Doesn't matter what you're calculating, either perimeter or area. Okay, so the fraction is the only thing that changes. The rest of the formula stays standard. Please don't go and mess that up. Okay, so the fraction changes, the rest of the formula stays as is. Once again, thank you for tuning in. Please stay tuned for our other videos that will come through this week. We are busy with the term 4 discussions now, so that we have enough time to do paper discussions on the exam papers for the end of year exams. Remember, both grade 8 and 9 are writing 2 papers, and I can just tell you now that paper 1 will consist of term 1 and 2 work, as well as graphs, which are the graphs, linear graphs that you draw on your Cartesian plane, as well as paper 2 will focus on all term 3 and 4 work. Once again, thank you for tuning in. Thank you for helping out to grow the channel. A huge shout out to everyone. See you next time.